Good evening. I hope that you'll excuse me for taking a bit of time in discussing this video. It's going to actually be a kind of a static video, in the sense that I'm going to try and explain to you the process that I took in notching out the section of the dovetail cutter that I'm making, a 60-degree dovetail cutter, solely because it took me such a long time. And if you've seen my other videos, the previous video indicated that this material comes from a great big chunk of I hope you can see that there. It's a 1 7/16 diameter. I think it's an axle shaft. It has to be, I would think. Maybe it's a rack and pinion, I don't know, but I would imagine it's an axle shaft, and it is really hard, really tough material, but the finish is very satisfying, providing that you are able to machine the material. So excuse me a minute, let's put that down. So when I machined, let's see if I can get a pointer of some kind. As usual, I'm not ready. Okay, if you can see this scriber that I have here, this is the shank, and this is the 60-degree angle that I machined in this 4-jaw chuck on the lathe, on the TIG lathe. And then once I'd finished machining the outside, I then took the chuck off the lathe and screwed it onto my dividing head. Came up against a few problems. The fact that the machine is so small and there's so little travel in directions that I was only able to clamp the base of the dividing head down with 2 3/16 studs and T-nuts. So I had another 2 slots over here that would have been nice to have been able to use as well, but because of the size of the machine I wasn't able to. So what I did was I put some more clamps with bars up against the base on this side that you can't see, and I also put a clamp here with the screw that comes up underneath the jaw. And the reason for that was that I didn't want this to unscrew while I was machining, or to move in a reverse direction. So I placed another clamp on there with a studding that comes up underneath the jaw, and that gives it extra support. I also used one of these, a adjustable parallel, I guess you'd call it. Very handy tools to have. A set of these is nice. So I placed that on the base there, and that goes underneath the arm there to give it support in the downward position. I decided, instead of doing it the way Randy Richards did his one, and he measured from the top of the largest diameter up there to find the heights. I didn't have I don't have a height gauge, vernier gauge or digital height gauge. So what I did, the only thing that I do have is one of these, and these are very handy units. I've used these several times in different jobs, and so what I did was I used a dial indicator and this to find the distance from the top down to the flat surface where the carbide insert is going to be screwed down onto. And what I'll do now is I'll move this camera around so that you can get a different view. Everything that I did was a little bit hairy in the sense that it's so easily to get a dig in, take too much off in one pass. The material, the hardness of the material that you're machining and so forth, and so I machined down. I first got my the right hand side edge with an edge finder, and then in using a 3/8 carbide end mill I calculated out the distance that this one face here has to move in to machine right down through the center and not too far over, but right on the center. And at the same time I had to be sure that I was getting the right depth from the top down to that face. So what I actually did was I used a dial indicator and I used the base of the table plus this shaper gauge, and the first thing I did was to measure or to dial in off of this adjustable parallel. I zeroed in on that, and then I placed the shaper unit and undid that and moved it down until I got a 0 on there. That allowed me to get a dimension from the table to that top surface. And once I'd got that surface, I knew exactly what the distance was from the top edge down to the center, because I knew the diameter of the workpiece, and I halved that, and then I added another 1/8 of an inch, which is the thickness of the insert. And so in that way I was able to calculate by getting the distance from here to here. I then knew what the difference from the base of this largest diameter up to that surface would be, and so I measured the distance from here to here until I got the right calculated distance, which was 2.075 in my case. It would change according to whatever you're using to hold the part. So then once I had this set at the right height for that face there, I knew then that once I zeroed onto here and transferred that 0 over onto there with the dial indicator, that I knew when I was exactly at the right depth to finish the cut. In this particular case I used a carbide 3/8 carbide end mill, 4 flute end mill, and I had 2 of them, and I probably only got down to maybe half the distance when the original the first end mill that I used, carbide end mill, it it got blunt and it started rubbing on the surface as I was going down, and of course I couldn't take a full cut. I was only taking light cuts because of the setup. It's very flimsy setup. I mean, it's just held by two 316 studs and a few clamps around the side, and that's basically it. So I was concerned about digging in and jerking and moving, maybe breaking the cutter. So the biggest problem was when you started getting down here in depth and up against the centerline face. I actually climb milled most of the material, but on the return pass, what I did actually was, because it was rubbing, I moved the z-axis up just 5 thou and wound the table back to the inside end here, and then of course I put on another cut, and that's how I went gradually, starting at this outer edge and then gradually moving in a little bit and moving down. And I found that at one point I was actually climb milling out, and because there was a sharp edge here, when the cutter was coming out, it actually dug in and wanted to almost broke the end mill. So I decided then that what I needed to do was to get a file and to actually hand file this edge at a 45 and put a bit of a chamfer on there, and that helped to eliminate any chance of a dig-in. I mean, obviously, if this just moves just slightly under pressure and the cutter doesn't move with it, it's gonna catch and dig, and there's a chance that you could have a dig in and lose your position, your angle, and everything. So that's how I did it. I actually had to hand sharpen the carbide end mill twice. First of all, I put 45 corners on each flute, and that helped for a while, and then the bottom cutting edge got worn, and so that made it like you could feel it was kind of, instead of cutting, it was kind of rubbing. So I eventually took the end mill out, and then I just hand ground the four bottom flutes, the cutting edges, and it worked. I managed to rough the unit down, and got the bottom within 5 thou, and that's when I took the worn cutter out and replaced it with a brand new one, and just took the final 5 thou off the bottom face and just rubbed and just cleaned up the vertical face. So now I have the cutter is ready for the insert, and so the only thing I can do now is to leave this set up until I get the inserts. They're in the mail, and then once I get the inserts, I can then use a pin that fits the hole of the insert nicely, and put it, guide it onto this face, and by moving the X and Y I can set the whole thing up, and then I know that that's the right position for the screw. And that's going to be the final part of this cutter. If it's successful, it's going to be a nice cutter, very, very strong, a good holder. And the only problem I have now is to make sure that I don't break a tap when I'm tapping. So what I'm going to do there is I'm going to make the hole, the tapping hole, larger, so that I have less thread to tap. Obviously less thread to hold, but I figure that if I just make it just that little bit bigger, it'll ease the tap, make it a little bit easier to tap, and it should hold. It should be plenty strong enough to hold. So that's about it. I did have a, hang on, I've got a, what did I do with it? Oh, here it is. Oh dear. Yes, so this is what I worked on to calculate the distance from the table. This here represents the bottom of the table, and this is the one adjustable gauge, and that's the dimensions that I came up with, and this was the final dimension required to allow the insert to be right on the center line. Obviously this is the opposite way round. The insert will be on this side. So I hope that's plain for you to understand. I'm sorry that there's no video of actual machining, but it was so long. I did it in a 3-day stage, and I just felt that because I can't edit, that it would be really quite a waste of time, and it wasn't perfect by any means. You know, what with the first carbide insert, carbide end mill rubbing, and not working very good, I just didn't feel that it was worthwhile to show something like that. So I figured that the final session would be sufficient. So I thank you all for watching my videos, and if you want to make any comments, that's fine.